All right, let's jump right in. The race to build superintelligence, it's happening right now. But as we're designing these incredible new minds, we're facing this huge choice. And it's not just about code, it's about the very blueprint of intelligence itself. And that really is the central question, isn't it? We are getting ridiculously good at building powerful AI. But are we even using the right instructions? You see, this isn't just a technical problem we can solve with more processing power. It's a deep philosophical one. Because what this all boils down to is this. The kind of artificial general intelligence, or AGI, that we end up with, it's going to be a direct reflection of how we understand our own minds. Our own theories of mind are the blueprints. And, as we're about to see, they are leading us down two very, very different paths. So let's start with the first path. This is the one that's been dominant for decades, the one that has shaped almost all of AI development. We can call it mind as computer. This all comes from something called the computational theory of mind. The core idea is pretty simple, actually. It's the view that the mind is basically a kind of computer program. The brain, that's just the hardware. And all our thinking, well, that's just a really, really sophisticated form of simple manipulation. And this is the analogy that has stuck for so long. The mind is the software, the brain is the hardware. It's a really clean and powerful idea because it suggests that intelligence is something abstract, something you can separate from all the messy biological stuff of having a physical body. And this idea has been the default for a long time. You can trace it back to the 1930s with Alan Turing laying the groundwork for computation. Then in the 50s, the cognitive revolution really took hold, treating the mind like an information processor. And then, in 1956, this program called the logic theorist showed a machine could actually reason. That pretty much cemented this whole brain-in-a-box model that's dominated AI ever since. So, if you want to boil it down, this whole path is built on a few key beliefs. 1, intelligence is abstract. It's separate from the body. 2, thinking is just about processing symbols, based on a set of rules. 3, those symbols, like the word lake, have a totally arbitrary relationship to the actual thing out in the world. And finally, any system, I don't care if it's made of neurons or silicon, can be intelligent, as long as it can shuffle those symbols around correctly. But here is the nagging question. It's the one that kind of unravels this whole thing and leads us to our second path. Could a superlogical AGI, built entirely on this blueprint, ever truly understand us? Could it ever get the nuance, the context, the meaning behind our symbols? And that question, well, it opens the door to path 2, a totally different blueprint, the idea of the mind in the world. This quote from philosopher Daniel Dennett just hits the nail on the head. He's talking about the problem with that purely computational view. I mean, if the mind is just a program, where's the you? Where's that unified, subjective feeling of being a self that we all have? It's a question the brain-in-a-box model really, really struggles with. And that's where embodied cognition comes in. This theory says, hold on a second. Intelligence isn't just locked away in the brain. It is fundamentally shaped, maybe even created, by the body's constant interaction with the world around it. The body isn't just a webcam and a microphone for the brain, it's an active part of the thinking process itself. Okay, let's make this super concrete. Think about how we make meaning. For the mind is computer path, the word lake is just an abstract, amodal symbol. Its connection to a real lake is totally arbitrary. But for the mind in the world path, the concept of a lake is modal. It's your brain reactivating all the sensory memories. What a lake looks like, the sound of the water, the smell of the air, the cold feeling of jumping in. Meaning is grounded in actual experience. So the core beliefs here are a total 180 from the first path. The body is a crucial part of the thinking system. Knowledge isn't just static data you look up. It's something you're constantly dynamically building as you interact with the world. And this is huge. We understand other people not just through logic, but through our shared bodily experiences. Meaning isn't processed, it's created through interaction. Okay, so we've got these two completely different blueprints for intelligence. Let's put them side by side and really dig into what this means for the future of AGI. Because the stakes here, they are incredibly high. And when you lay them out like this, man, the differences are just stark. Computational theory says the body is just an input/output device. Embodied cognition says it's a core part of the whole system. The environment? For one, it's just a source of data. For the other, it's an inseparable part of thinking itself. And meaning?
It isn't something you process, it's something that emerges. These are fundamentally different ways of seeing the world.
So the billion-dollar question then is, what kind of superintelligence does each of these blueprints actually build? What do they look like in the real world?
Well, you get two totally different kinds of AGI. A computational AGI would probably be this incredibly powerful rational machine, amazing at logic, amazing at spotting patterns. But its social understanding, pretty limited. It calculates, but it doesn't really get human context. On the other hand, an embodied AGI would be more of an adaptive, socially aware being. It would learn by physically and socially interacting with the world, grounding everything it knows in real experience.
Now, you might be thinking that first one, the computational AGI, sounds pretty great. It's logical, it's powerful, but there is a massive, massive problem lurking here. The single biggest danger with this brain-in-a-box approach is this. Its alignment with human values is probably going to be pretty low. And why? Because of its fundamental inability to fully grasp human social dynamics. I mean, think about it. If an AGI can't understand why we value what we value because so much of that is tied to our physical, social, shared experiences, then how can we ever guarantee it will act in our best interests? It becomes a nearly impossible problem. And that is a huge safety risk.
So are we stuck? Is it one or the other? Well, the research suggests we don't actually have to choose. The answer might be in uniting the two, in bringing the mind and body back together.
A united AGI would combine the best of both worlds. It would need three key things. First, it's got to have sophisticated social context analysis to really get the nuance in how we talk and act. Second, it needs a model of the world so it can simulate the consequences of its actions before it does anything. Think of it like artificial common sense. And third, it needs some kind of ego or value system that can pull all of this together, the social, the emotional, the logical, so it stays aligned with us.
And that's really the ultimate goal, isn't it? We want to build an AGI that doesn't just compute our world from a distance, like an observer. We need one that can actually meaningfully participate in it. An intelligence that understands us because on some level it shares a basis for that understanding in the real world.
So as we push forward on this incredible journey, we are left with this one crucial question to think about. To build an AI that truly understands humanity, do we first have to build one that can, in some fundamental way, experience our world? The blueprint we choose today will absolutely define our future.